This is Tim Doyle with Festo US coming at you from the Chicago office. I have a quick video for you covering the SMS Rockwell AOI. You can see in the lower left corner my current setup, which is a Rockwell controller connected to a CPX API, which has an IO link master that is connected to our SMS drive, the ELGS. If you'd like to see how to connect this to Studio 5000, please review our video in the upper right hand corner. To begin, we need to have our AOI enabled, and we need to have our SMS powered, which we currently have those states going for us. Right now, I have our speed set at 1 going in and out. I have our force set at 5, and all increments here are set between 1 and 10, in 10% increments of what the drive can do. I have the force set at 5, so it can overcome some of the mechanical properties that are naturally inherent with these types of systems, just so I could demo this. I have a start press position at 25 millimeters, and as you can see, that is written as 2500. We have that set up in our current system as a decimal place so if you like to go 30 millimeters, you need to set that up as 3000. If you'd like to go 67 millimeters, you need to set that as at 6700. We have an end position set up at 9500, and we can see our AOI is currently here, and we have a bunch of tags referencing our AOI, so we can change those from here. We also have a few of our feedback. We have our current position, our current speed, our current force, temperature, and normal current and voltage. Those will review as we go on. From here, we have our system referenced, and then we will unreference that, and then we'll move out. As you can see, the system moved out to 25 millimeters, and once it hit 25 millimeters, it slowed down drastically because there is looking to apply a force. So we'll move that back, and we'll try to make that a little bit more drastic change. And I'm going to change the speed in to 5. I'm going to change the speed out to 9. So we'll see it whip to 25 millimeters and then slow down drastically to apply force. As you can see that it whipped to 25 millimeters, slow down to apply the force, and then we are going to stop that movement, and then we're going to move back to position. We can also move to just the intermediate position, which we currently have at 25 millimeters. Moving out, it'll be quick, and then we'll move in. We could change that intermediate position on the fly too, so we'll go move out to 25 millimeters. We'll stop that. We'll change our intermediate position to, let's say, 47 millimeters. And then we'll move to that intermediate position again. And as you can see, beyond that 25 millimeters, we are again in our pressing position. So to get a better sense of that, I'm going to change our start press position to match our end of length, which is 95 millimeters. I'm going to move back to our start position, and then I'm going to change our intermediate position to 25 millimeters again, and we're going to move to the intermediate. I'm then going to change that to 67 millimeters, and then we're going to move to that again. And then we can move to end position and move back to start position. We can also move to the end position to our intermediate position, and we can change that on the fly on the way back as well. Set that to 10 millimeters. and then we can go back to our start position. You do need to end your movement before you can change the position again. With that said, we'll move on to covering our force, and right now I have a stick to be able to simulate that. So our current force is at roughly 50% of the total amount of force that we can provide. I'm going to change our start press position to roughly 25 millimeters again. And then I'm going to begin our pressing application, which we'll move quickly to 25 millimeters, we'll then slow down, and then we'll apply force to our pencil that's currently in our way. So we'll move out, moved into position, we're now applying a force. We can now see that force with our feedback, and we currently have roughly 50% of what we can provide here. Current position, we can also see current speed, which should be roughly 0, but that usually bounces. And then we're going to stop applying a force just by stopping our move out, which is still providing a little bit of force with feedback, but then we're going to move back to our home position. I'm then going to move that force up to, let's say, 80%. And same thing. We'll move out, we'll apply a force, and we should see roughly about 80% here. Same position. All these tags on the AOI can be referenced. It can also be written. And I believe that is a good introduction to our AOI. Thank you for watching, and hopefully see you again.